Hey, what's up guys? My name is Cherno and welcome to another episode of this Genesis series. So we're taking a look at one of the first games I've ever made and seeing what we can do to fix some of the problems and just, going over the code, having fun with it and stuff like that. So last time we took a look at the lighting engine, quote unquote, so to speak. Where'd my continue button go? And yeah, I mean, we talked about, I must have spelled the time as well. We talked about how these lighting tiles actually work. And then this episode, I said that I would talk about how the mob lighting works, right? Because what happens is as a mob approaches a light, as you'll see in a minute, the mob kind of gets lighter, right? And you can kind of see that happening here. Now, there is a bit of a bug with it where it doesn't actually happen all the time. It should though. You can see that it's not, like for example, I'm still lit here for some reason. That's something we need to talk about. But anyway, how does this system even work in the first place? That's what we're going to answer today. Excuse me. I mean, I have no idea right now, so we're gonna learn this together. If I can stop coughing. So, step one is going to be to take a look at how mobs are rendered in the first place. So I can already kind of see this in my head because every game that I make is fairly similar, but I believe we should have a function here that renders mobs, and then every mob will probably have its own render function. So take a look at this. We have entities.render. So every entity class has a render function, which, as far as the hierarchy goes, we have mob, which extends entity, so that has its own render function as well. I mean, this one's not any different than the other one, but I did just find a function called render lighting, which looks promising. And then if we go to say player, for example, I'm sure that the player will have a render function. Oh wow! Look at all these. Spawn female. Look at all these functions. Anyway, there's render. And then render has, what do we have in render? We have our animation stuff. We have which sprite we pick, basically. That's an awful way of doing it, but anyway. We have screen.render mob. Okay, so that's in the screen class. And then we have render lighting, which takes in statically the light tiles. And render lighting is that function that we found in mob. So let's take a look at this. This happens for every single mob, I assume. If we go to like female or something, then we have render lighting. If we go into, what are the other ones called? So let's see what we have here. Entity mob. So maybe like just forest mob. I think forest mob was actually the regular ones. Sprite.player3. I have no idea. Anyway, yeah, I mean, they do this as well. So first of all, it looks like we render the mob independently from the lighting, which again is a bit weird. If we take a look at what player does, we do render mob, which seems to actually render. Seriously, what is this? Anyway, I think that was from actually one of these episodes. Yeah, it was weird. I do remember that. Anyway, and then we actually rendered this. I mean, it looks like we do lighting here though, so I'm not exactly sure like what that is, because you can see that we do the mob.light distance times level brightness times some weird number. And then we actually do the change brightness. So I'm actually curious as to what render lighting actually does. So let's take a look at it, because it is being called. Oh, I see. I think we just work out the light distance. That's probably it. Yeah, because we pass in the light distance, right? Yeah, mob.lightDist. Okay. So I'm learning a little bit here. So what seems to be happening, I'm just gonna have some water. Real professional. So what seems to be happening is we seem to be having, this should probably be the other way around anyway. So render lighting actually seems to, all it really seems to do is calculate this field that we have called light distance, right? And it does that with a few different, in a few different ways. I mean, ultimately, it is a distance, and then finally, if the distance is greater than 100, we end up with -1. So if we go through this real quick, so we have a light size, which is an interesting value. And then what we do is we go through every light tile on the entire map, it would look like. Or I think that list gets dynamically generated actually. Because that gets passed in from here, which is in light tile.light tiles. And I believe that gets populated. Yeah, that's right. It does get dynamically generated. I remember now. Because we have light tiles.clear here. So the light tiles essentially get added. But these are the level light tiles, not the light tiles inside light tile. I don't know why we have two in the first place, but... oh, so we call render. Oh, but when we create it, it has it statically anyway. What? Hang on a minute. I am slightly confused now. How exactly does that work? Hold your horses. How does that work? Because when does that get cleared? When does this list get cleared? The one that's in light tile. And why is it even used? I mean, it's used for the... Oh, hang on a minute. I think I may have just discovered why the bug is there. I don't think that gets cleared. Let's just try this for fun. Light tiles light tiles dot size. Okay, so no, it does get cleared. Where does it get cleared though? Oh, and it's also it's not the actual light tiles, it's just, yeah, the torch tiles really. Okay, so we must be clearing it somewhere. Let's just see where that's happening. It'll be called like, how do you search globally? I think it's this, .clear. In the game class. Yeah, there it is. Okay, cool. So after we render the level in the game class, we call light tiles.clear. All right, good. So that's there. Okay, fair enough. Just had to make sure that was actually happening. Okay, so then we go through all of our light tiles. We calculate okay, so the light tile position, I assume then, would be in terms of tiles, because what we're doing there is we're multiplying it by 16, which will take it up to be in pixels. So basically what this is it's working out the pixel boundaries of the actual tile that the light is on. So basically this would be a bounding box, essentially a bounding box for the torch tile. And then this is figuring out the center X and center Y, as the name would imply. This is going to be the center, or the average of course, the horizontal and vertical bounds, which is the center of the tile. And then we have this wonderful code. So what is the center even used for? Oh, okay, that's later on. Oh, for the distance. Yeah, that would make sense. Okay, so this dot X, so if this dot X is greater than, I see. Okay. So essentially what we're doing here, what we should be doing here, 48 by the way is a product of, it's 16 times 3, okay, because a tile extends, yes, a light tile can cast light up to 3 tiles, like in like a 3 tile kind of radius. So you'll see here in a minute. We have the torch tile and then 1, 2, 3. Okay, so that's what that 48 is. It's essentially 3 times 16, so 48 pixels. And we're basically saying if this mob is within that boundary, yeah, then we can actually work out the distance, I guess, that it is from the light. But I'm not sure why that requires a for loop exactly, or 2 for loops for that matter. Okay, sure. Oh, yeah, this is interesting. This is interesting. Okay, so what are we looping between? Oh my goodness. Yeah, this really is bad. This is... So we're going through every single pixel. Oh my goodness. We're not even using it. I am shocked at this code. Goodness me, I hope Java optimized that by removing it. Goodness me. That must have been a completely different... This is what happens when you don't think. So this part of the code is completely unnecessary. Oh my goodness me. So let's rewrite this function quickly. It might even solve our bug. It probably won't. I mean, it might. So let's see what we don't need. That. So let's do this. Let's set light distance to be a -1. We have to also remember, by the way, that we're doing this for each light tile. So the light distance -1 we should set to be here. We need to find a better way to stay in shape would be to actually find the closest light tile first. Because it's kind of, in this case, it's going to kind of use because if there are two lights that are intersecting, we want to get the closest one anyway. But a better way to do that might be something like this, where we have, let's just say we're in the bounds, right? So we need to do that, check. So we assign light distance, and we need to quickly check to see if it's, we can do something like, if it's less than 100, or to keep it exactly the same, less than or equal to 100, that's when we actually assign it. So we have our distance. I think that's a double, right? As in our light dist was a double, yep. So we have our distance. If that distance falls into one of our accepted kind of parameters, then we actually assign it. And I guess we would also want to do the minimum of that, possibly. So, I mean, this would work. I believe this would do the same as what this did, right? Yeah, because we override it anyway. So really it's whatever. Oh, I know why this whole thing fails. Oh no, actually no, that wouldn't cause that, would it? Because we have to be in the bounds for it to count. But also it can't be above 100. This is all a bit weird, to be honest. Let's just see what this gives us. A faster game is the first answer. Okay, so there's that whole notion of completely no lighting, which is okay for now. Actually seems to work pretty well. I mean, it's definitely not causing any problems here. Let's see if we can breed a little bit. If I can find a woman. Come on. Where are you at? There you are. Come here. Wish I had that mini map. In fact, I can probably just enable it. Alright, so we have a female at about 8 o'clock. Come here. Alright, 2 more up there. Okay, so this should be enough, I think, for our experiment. Okay, so there we go. I mean, she definitely did fade in. Okay, let's see if there are still any bugs with lighting here, at least. Hang on, I can't help myself. That actually seems to work pretty well. And we do have that abrupt, like, fade out, but yeah, and he totally worked. Yeah, that looks pretty good to me. Looks like that did fix it. I mean, we did need to tune up the radius and stuff. All right, there you go. So, yeah, I mean, moral of the story is don't write ridiculous code. What is up with that? I just don't get. I just don't get it at all. I mean, honestly, this is how I would do this function if I had to rewrite it properly, actually. So first of all, let's just be clear that this is really supposed to be tile size, which I don't even think we have as a constant, but 16 times 3, so that we actually know what that is. Still not 100% sure we actually need to have that, but anyway. We're gonna first of all loop through all of those light tiles, all right, which we can do using a for each loop. Light tile in these light tiles, which I called LT and not light tiles, but anyway. So here's what we're doing. We're trying to find the minimum most light tile. So we have a light tile that we actually have selected. So we'll call this light tile, which is equal to null. And we're going to loop through all these tiles. We're going to get the distance of that light tile, or I mean, we could work out whether or not it's essentially in the bounds if we really wanted to. So to do that bounce check, again, we're just going to do that. This, of course, gets replaced with this. And this is if we still want to do the bounce check, which we don't really have to, but I mean, we can if we want. We then check to see if the mob is inside that. All right. So if this.x, let's just verify that that's all correct. Lx 0, yep, okay, that math checks out. So we can basically just say that if that's false, if that whole expression is false, we can continue on to the next tile, right? Otherwise, if it's not false, our candidate kind of moves up. So what we do now is we check to see if light tile is null. We can do a distance check as well. Oh, well, actually, this would mean that the mob would actually be in the bounds, which means that we do have to actually do the light tile check, I think. So we basically just found our light tile, right? So light tile is going to equal tile, okay? At this point, if light tile is null, then we return. There's nothing to do, okay? We are not in light, so we stay the same. Otherwise, we do actually have to apply lighting. So we no longer need this now, or the bounds. The center X can stay, and we'll sort it out in a different way, I think. So the center of the light is what we're interested in. So again, we can just kind of do that check here. Maybe we should, nah, the bounds, I'm not really interested in that. We know what LX1 is going to be anyway. So we can just basically do, I mean, all we really need to do here to get the center of the light is just say light tile.x plus 8, okay, or plus 16 divided by 2. I'm just going to do plus 8. That's going to be the center, right? We don't need to do anything special. We know that's going to be the center. Again, I would do a tile.size divided by 2 or whatever if I had that constant somewhere, but it doesn't look like I do. And then finally, we don't need this check anymore, which is nice. We just need to work out the distance and update it if we need to update it, right? So we still use this.x, which we can actually just write as x, and this.y as well. We don't need to do the absolute thing because we're squaring the number anyway, which means that it will be positive in the end. And finally, we're square rooting it. So this is pretty simple kind of Pythagoras theorem to work out the distance. Now, if the distance is less than 100, then we end up updating the distance. Otherwise, we keep it as -1. I might actually end up changing that. It's a good idea to set it to -1 all the time anyway, because that way, if we do return as we do here, it will get set to -1. Because obviously that means that we're not in light, so we really only have to work it out if there is a light. But yeah, we can set the distance to distance. 100 might not be the best value to actually set here. Before we actually managed to kind of smooth it out somehow. Which is a bit, I'm not sure exactly how that worked though, because it looks like our logic's the same. Not sure. But I mean, if we take a look at 3 tiles, that's 16, 16, 16, 48. The max distance that we can actually be away from the light, which is the center, remember? So if we pop open a calculator, we have the 48. We have the 48. Switch over here. We have the 48. We have another 8 to get to the center, right? I'm assuming that the x it takes from the mob is also centered. Just assume it is, okay? So it's essentially going to be 56 plus 56, or rather 56 squared plus 56 squared, and then the square root of that. So we can be a maximum of about 80, let's just say. So I'm not sure why that exactly gets set like that. 100 seems weird. I don't know. I'm not sure that we actually need that, to be honest. Because after a while it will be too long anyway. Let's just see what that looks like. I'll get rid of the map. Or actually I'll keep it. Okay, so we do turn black immediately. When we actually enter yeah, I guess that's why. No, but hang on. That means that it's -1, right? Let's go to the player and let's just print the players. I also don't like the fact that we are doing this in reverse. But anyway, let's print the player's light distance. And let's stop printing the light tile size. -1. Yeah, so we're -1, and then when we enter a light, we get a value 800. Hold on a minute. That's not right. At all. What? Why done? What? Oh, I know what I've done. Lol. Yeah, soz. This needs to, this is in tiles. That needs to step up. Whoops. Takes a while sometimes. Okay, so there you go. I mean, it's still not really the smoothest transition here. But that's, again, that's to do with the fact that our lighting curve is not really accurate. But in terms of being bug-free, this should be completely perfect. And it also should be very, very, so you can see that number as we calculated there on the calculator was like 79 was the max or something. So you can see that, yeah, right about there's the max we can actually get away from it. We can never be further away than 80. Yeah, so we should be completely bug-free here. Again, that lighting curve does need a bit of an adjustment. I think we calculate that in screen probably, where we check to see if it's -1 when we actually rendered the mob lighting. So yeah, if it's less than 0, we set it to the level brightness. So maybe we can set it a little bit brighter than that. I don't know exactly how bright I want it, but if we just set it a little bit brighter, just so it doesn't pop as much. What is it anyway? Level brightness. What is level brightness? Let's just up that a bit. Oh wow. Bit too bright. Anyway, you can kind of see what I'm doing here. Oh, but that's going to change, isn't it? Yeah, that's a bad idea what I'm doing. Because that, yeah, that goes with the brightness. Oof. All right, new plan. It's the only real new plan I can possibly have is changing the curve of the brightness to match that, which would mean that we'd be reduced to level brightness. And the way you could do that is a few different ways. First of all, we'd have to make sure that if color was somehow below level brightness, then we made sure that it wasn't, right? So the way we do that is when we decide to change it, which is new color, we'll call it. If this new color is below, or rather, hang on, I'm doing the wrong thing. We get our intended brightness, which is this, which is an integer, by the way. We first of all check to see if this brightness is below. So if this brightness is below level brightness, then we basically have to set brightness to be level brightness. Okay, so that way we can never go darker with this. And then after that, it's just gonna be a matter of changing that curve, right? So that's almost perfect. And there you go. Nope, still a bit of a pop. Maybe even 2. Hard to see in daylight, obviously. You should be able to watch the other mobs as well. Yep, you can see that this gives us a perfectly smooth transition with absolutely no pop, and that's kind of the idea. Yeah, that actually looks quite nice. So there you go. That's one way to do it. And it should be perfecto. Yep, looks pretty good to me. Okay, so that's essentially how mob lighting works. It's pretty simple. All we do, essentially, is we use a function to calculate how bright a mob should be based on its position in relation to a light source. And that's all then that's just going to be a value. It's a distance value. And then when it comes time to render the mob, we change the mob's brightness by darkening the pixels if it's further away from the light. That's it. It's very, very simple. We do that for every mob, as you can see. And I mean, I rewrote this to be a little bit less chaotic, which probably greatly increased our frame rate, by the way. We can actually do a bit of a benchmark. I mean, I don't know if it actually did, because I think that Java would strip these for loops. It might not, though. So let's actually give that a test just for fun. I want to find that print line that I had. What would that be? That was the, yeah, that would be in player. Okay, so with the old method, so this is the new method. With the old method, we go to the map, map. All right. Let's find the island. That's going to be our benchmark. Really? Okay, I'm actually just going to disable every single level. Except for the one that I don't even know how to do this. Where is the play button? Level.play equals true. Oh, that's right. It's not even a function. It's just a state. So weird. I really hate that. Yeah, play menu biome is correct. So where is that referenced? Oh, that's when it changes. I don't even know where this is. I actually don't know where this is. Well, that looks promising. Wait, what's this? You get to select which map you want to play on. That's not true. Oh, there used to be a play menu, didn't there? Desert. Wow. Cool stuff. Pretty cool stuff. Ambitious. I like it. Anyway, here it is. So it's in game over menu. No, that must be the wrong one then. So playmenu.biome is the one you're supposed to set, I think. Just search for that. Okay, it's in main menu as well. There it is. So we'll set that to 2. Yep. Okay, so get about 1,000 FPS. I mean, there aren't too many mobs here. So this is the old method, by the way. 1,000. I don't know if this will be any faster actually, because there's only one mob. It shouldn't be slower though. That's what we're going for, not slower. Okay, so it's about the same speed. Maybe a little bit faster. It's hitting 1150, 1200. When we're actually inside and it has to do the calculation, it's still pretty fast actually. I'd say overall it's a bit faster. You can see how nice that kind of fade in is and stuff. It's quite nice. I mean, obviously I could sit here and tweak it and make it even better and make it more perfect. But I'm pretty happy with the way this is because that's not what this is about anyway. All right, anyway, that's going to wrap up this episode. Hope you guys enjoyed. Leave any questions or concerns or thoughts in the comments below. Yeah, don't forget to like the video as well if you liked it. Next time, I think we'll cover maybe the actual mechanics of the game, such as the breeding mechanic. I don't know. Leave a comment, in fact, on what you want to see next. I'm probably going to start covering the logic now because the graphics have been basically covered. We fixed a bug, which is cool. So the lighting bug's fixed now, I think. I haven't tested it thoroughly, but I'm just going to assume it's fixed. You know what I mean? But yeah, leave a comment below with what you want to see next as far as this game goes. But otherwise, I think I'm going to probably start covering the actual game, like the game flow maybe. I'll start off with maybe covering like all the game states and the game flow, and then maybe move on to stuff like how the mobs work and maybe how the entities work and how the breeding works and all that stuff. I don't know. We'll get to that. Anyway, thanks for watching this episode. If you guys enjoyed, please hit the like button. Of course, follow me on Twitter. Link will be in the description below, and I'll see you guys next time. Goodbye. Vroom.